Hey guys, welcome back to another video. Today we're going to be doing something different and attempting this very interesting question that is not part of the UKMT. So, let's begin. So, a circular clock face, centre O, has a minute hand OA and an hour hand OB. OA equals 10 and OB equals 7. Calculate the length of AB when the hands show 5 o'clock. Give your answer correct to 3 significant figures. So we can write our mind map, or do our mind map. So we have centre O, and that has minute hand, which is OA, and shorter hour hand, which is OB, and then we know that the length of OA is 10 centimeters and the length of OB is 7 centimeters. Calculate the length of AB when the hands show 5 o'clock. Calculate the length of AB when the hands both show 5 o'clock. Circle with our center, which is O, and then we have A, and then we have B, and then we know the length is 10 here and 7 here, and we want to find the length of A to B. So we can rub out this point, and then we've been given a angle. Well, we don't know what the angle is, but we're given that there's an angle that's drawn there. And then we have our pointers, so we have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. So obviously they're not evenly they will be evenly spaced because it's a clock, so I haven't drawn it accurately, but that's it. So we know that there are there's 360 degrees in a circle, and we know that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So we do 360 over 12, which gets us to 30. So now we know that each space, so these angles are 30 degrees. So each of these are 30. So we can write 30 here. So this will help us find out the angle of AOB. 30 plus 30, which is 60. 60 plus 30 is 90. 90 plus 30 is 120, and 120 plus 30 is 150. So now we know that this angle is 150 degrees. So now, to find AB, we can use the set cosine rule. So the cosine rule. So this is a set rule which involves finding the lengths of an opposite of a length that is opposite to the angle of that triangle. And it doesn't have to be with right angles, as we know with sine, cos, tan, and the Pythagoras theorem. So this rule is AB squared. So in this case, it would be AB squared equals AO squared plus OB squared minus 2AB times cos 100 cos angle. So if we label those ones, so we have AB squared. So we have AB squared, which is just our normal that. Then we have 8O squared, which is the length of 10, and squared that. And then we have the length of OB, which is, we know is 7 squared. And then we have minus 2AB. So 2AB would basically be the lengths of this, of A, and of here. So 2 times this length times that length, times cos angle, which is 150. We know the angle of the triangle is 150. So AB squared, so we still don't know what AB is. So AB squared equals AO, which we know is 10 squared, plus OB, which we know is 7 squared, minus, so 2 times 10, which is 20, times 7, which is 140. So minus 140 times cos 150. So we know 10 squared is 100, plus 49 minus 140 times cos 150. So that's 149 minus 140 times cos 150. So to find cos 150, it's a set value, which is minus root 3 divided by 2. So we would figure out the BIDMAS. Using BIDMAS, we would do minus 140 times minus root 3 divided by 2, which is, if we simplify it further, we get minus 70 times minus root 3, and then we know that would be plus, and then using a calculator, you find that the answer is 121.24 to 2 decimal places. So now you've got the value of minus 140 times cos 150, you would just add 149 to that, so 149 plus 121.24, which is 270.24 to 2 decimal places. So now we've got a value for AB squared. So AB squared equals 270.24. So obviously, rearranging it, you would get AB, solving it, would be AB equals square root of 270.24, which using a calculator, you get 16.44 and then so on. But to 3 significant figures, that would just be 16.4 to 3 significant figures. So the answer would be 16.4 centimeters for AB. So thank you guys for watching our video. Please make sure to like, comment and subscribe, and we'll see you in next time's video. Bye.